In the late 1970s, a distinct sound vanished from the Midwestern hayfields. For decades, American farmers buying a heavy-duty pull-type baler expected a massive piece of cast iron bolted to the top, a Wisconsin V4 engine. It was a completely independent power plant, running its own fuel and heavy exhaust rhythm, entirely separate from the tractor pulling it. Then the dealer orders stopped. Farm tractors had grown significantly more powerful, making the live power takeoff, a spinning driveline shaft that transferred mechanical power directly to the towed implement. The industry standard. The baler no longer needed its own heavy-duty engine. The displacement was devastating. Wisconsin Motor Manufacturing Company, the Milwaukee industrial giant that built America's most indestructible air-cooled engines, suddenly found its masterpiece rendered unnecessary. The company was absorbed into Teledyne, and the agricultural market was quickly flooded by cheap, lightweight aluminum imports. The paradox was brutal. The Wisconsin V4 did not break. It was simply over-engineered for a market shifting toward cheap replacement over generational durability. But the real story of Wisconsin Motors is not only about a forgotten baler engine. It is the story of how America powered its heaviest work before every machine became lightweight and disposable. Every week, we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place in Milwaukee, Wisconsin, in 1909. In 1909, the industrial corridor of Milwaukee, Wisconsin, was rapidly becoming one of the most important manufacturing centers on Earth. The city was built on heavy industry, steel, foundries, and the kind of skilled machining labor that could turn raw metal into reliable kinetic energy. It was here that Charles John and Arthur Warner founded the Wisconsin Motor Manufacturing Company. But the company did not begin its life building the agricultural workhorses that would later define its name. It began with speed. In its earliest days, Wisconsin built high-performance, water-cooled automotive engines. Throughout the 1910s, if an American driver wanted to go fast, they looked to Wisconsin Power. The legendary Stutz Bearcat, one of America's earliest and most famous sports cars, relied on a massive Wisconsin T-head engine to dominate early racing circuits and establish a reputation for relentless speed. Wisconsin engines powered early race cars at the Indianapolis 500 and moved luxury automobiles across a rapidly paving nation. But by the 1920s, the American automotive landscape was changing. Detroit was consolidating power. General Motors and Ford were building massive, vertically integrated assembly plants, and the era of the independent automotive engine supplier was beginning to close. Wisconsin's leadership looked at the market and realized a brutal truth. They could not survive a volume war against Detroit. If the company wanted to live, it had to find a different kind of work. They looked away from the paved roads and looked toward the dirt. In the 1920s and 1930s, the American map was divided. Cities were electrifying, and factories were drawing power from massive central grids. But rural America, the logging camps in the Pacific Northwest, the oil fields of Texas, the highway construction sites across the Midwest, and millions of sprawling acres of farmland had no electrical grid. If a crew needed to run a concrete mixer, pump water from a deep well, power a sawmill, or operate a heavy mechanical thresher, they needed a stationary engine. A stationary engine, a standalone motor designed to run in one place and power external equipment, was the only way to generate mechanical force in the middle of nowhere. But early stationary engines were massive, complicated, and almost universally water-cooled. They required a radiator, hoses, a water pump, and a constant supply of liquid coolant. In the brutal operational reality of American physical labor, water was a liability. In the dead of a Midwestern winter, the water inside an idle engine would freeze, expanding and cracking the cast iron block. In the blistering heat of a Kansas summer harvest, the dusty air would clog the radiator fins, causing the coolant to boil over and the engine to seize. American farmers, miners, and construction crews did not just need power. They needed power that refused to die, no matter how badly it was treated. Wisconsin made a radical decision. They abandoned the automotive market entirely. They would not build car engines, and they would not build water-cooled engines. Instead, they committed the entire future of the Milwaukee factory to building heavy-duty, air-cooled engines. An air-cooled engine, an engine that relies on metal cooling fins cast directly into the cylinder head and block, using a fan driven by the crankshaft to force air across the metal, eliminated the radiator, the water pump, the hoses, and the coolant. It could not freeze in January and it could not boil over in August. But Wisconsin did not build lightweight, fragile engines. While other manufacturers were beginning to experiment with lighter materials for small household chores, Wisconsin committed to heavy metal. They built their engines out of cast iron. Cast iron, a heavy, dense metal alloy that absorbs vibration, resists warping under extreme heat, and provides a massive, rigid foundation for internal parts, was expensive to pour and heavy to transport. But it was virtually indestructible. Inside the factory in Milwaukee, machinists assembled these engines like bank vaults. The block, the main engine structure that holds the cylinders and major internal parts, was cast thick enough to withstand decades of continuous vibration. The crankshaft, the rotating shaft that turns piston motion into rotational power, was forged from high-strength steel and rode on massive tapered roller bearings, a premium design choice usually reserved for heavy trucks, allowing the engine to handle extreme side loads from heavy drive belts. By the 1930s, Wisconsin began rolling out a line of single-cylinder and multi-cylinder, air-cooled cast iron engines. The early models, ranging from compact singles to larger inline fours, were immediately embraced by the American industrial sector. A mechanic at a rural repair shop could open a Wisconsin engine, examine the massive connecting rod, the part that links the piston to the crankshaft, and instantly understand that this machine was not designed to be replaced. It was designed to be overhauled. Overhaul, a major service process where an engine is taken apart, inspected, and rebuilt to operating standards, was the rhythm of American mechanical life. When a Wisconsin engine eventually lost compression after thousands of hours of brutal labor, a farmer did not throw it away. They bored the cylinder, installed a new oversized piston, and sent the machine back to the field for another 20 years. This mechanical philosophy built an unbreakable trust. Dealership networks across the country began to stock Wisconsin parts. Construction companies specified Wisconsin power for their pumps and generators. The rhythmic, heavy exhaust note of a cast-iron Wisconsin single-cylinder engine became the background noise of the American infrastructure boom. The company had successfully pivoted from the glamour of the racetrack to the grinding reality of the dirt. But the true test of the Wisconsin empire was not just pumping water or mixing concrete. The real challenge was waiting in the sprawling agricultural fields of the Midwest, where a new generation of farm equipment was about to demand more continuous, independent horsepower than any single machine had ever required. The block was ready. America still had to decide exactly how much weight it was willing to pull into the fields. To understand how a company in Milwaukee came to dominate the American dirt, you have to understand a fundamental mechanical problem on the American farm in the 1930s and 1940s. During this era, tractors were replacing horses, but they were still relatively small and low on horsepower. When a farmer needed to harvest a crop, they used pull-type implements, heavy specialized farm machines like combine harvesters or hay balers that were towed behind a tractor. The tractor provided the pulling force to move the equipment across the field, but the implement itself, the heavy steel plungers, the spinning threshing cylinders, the augers and the tying mechanisms, required its own mechanical power to operate. Early tractors had primitive power takeoff systems, or PTOs, to transfer power to the implement. But these early PTOs were directly tied to the tractor's transmission. If the farmer stepped on the tractor's clutch to stop moving, the PTO stopped spinning. If a massive clump of thick, wet hay jammed the baler, the farmer had to stop the tractor, but doing so would instantly kill the momentum of the baler, causing the whole system to plug up and fail. The baler needed constant, uninterrupted torque, twisting force felt as the pulling strength of the engine, to keep its heavy internal flywheels spinning, regardless of what the tractor was doing. The only way to solve this was to mount a completely independent engine directly onto the baler. It had to be compact enough to fit on the implement, powerful enough to compress hundreds of pounds of hay, and rugged enough to survive violent, shaking vibration in a cloud of thick, flammable dust. Wisconsin answered this problem by introducing an engine that would change the sound of American agriculture: the heavy-duty, air-cooled V4. A V4 is a four-cylinder engine with the cylinders arranged in two banks in a V shape, sharing a common crankshaft. This layout allowed Wisconsin to pack the power of a four-cylinder motor into a short, boxy, incredibly rigid cast-iron block. In 1939, Wisconsin launched the VE4 model, a legendary V4 that produced around 21 horsepower. In modern terms, 21 horsepower seems small, but in a 1940s Midwestern hayfield, a true continuous 21 horsepower, generated by a heavy cast-iron block spinning at a steady 2,000 RPM, was an unstoppable force. When an American farmer bought a pull-type baler from the New Holland Machine Company, it often arrived with a Wisconsin VE4, or the later, more powerful VF4 sitting proudly on top. The tractor would pull the rig, but the Wisconsin engine did the actual heavy lifting. The farmer would set the throttle on the Wisconsin to a wide-open scream, and the engine would run at a continuous, deafening RPM all day long. If the tractor had to slow down for a ditch, the Wisconsin VF4 kept the baler's mechanisms spinning at full speed. It was a symphony of standalone American mechanical independence. But Wisconsin did not just rely on heavy iron to earn the American farmer's trust. They engineered the engine to survive isolation. Farm equipment was often left sitting in unheated barns or open machine sheds for 6 months out of the year. A traditional automotive engine relied on a battery to start, but batteries died in the cold, and charging equipment was rare on rural homesteads. To bypass this, Wisconsin engines relied heavily on magneto ignition. A magneto is a self-contained electrical generator bolted directly to the engine that creates the spark for the spark plugs using the rotational movement of the engine itself, completely eliminating the need for an external battery. A farmer could leave a baler in a shed through a brutal Minnesota winter, walk out in the spring, engage the heavy hand crank, and the magneto would instantly generate the spark to fire the engine. It was a machine that required no outside help to wake up. This combination of heavy cast-iron durability, air-cooled simplicity, and battery-free magneto ignition made the Wisconsin V4 the ultimate off-grid power plant. The breakthrough was not just agricultural. Word of the engine's indestructible nature spread rapidly across the American industrial landscape. If an engine could survive the choking dust and constant vibration of a hay baler, it could survive anything. Jaeger Machine Company began bolting Wisconsin engines to their heavy concrete mixers, relying on the air-cooled iron to run continuously on dusty, sweltering road construction sites. Lincoln Electric paired Wisconsin engines with their portable industrial welders, allowing crews to weld steel pipelines in the middle of the Texas desert where no electrical grid existed. Trenchers, heavy water pumps, and oilfield pump jacks were suddenly powered by the distinct, rhythmic thud of a Wisconsin V4. The Milwaukee factory was no longer just building engines. It was building the prime movers for an entire secondary layer of American infrastructure. Dealerships across the Great Plains and the industrial Midwest stocked Wisconsin parts as standard inventory. Mechanics memorized the sound of the valves, knowing that if a Wisconsin engine started to smoke, it didn't mean the engine was dead. It just meant it was time for an overhaul. By the end of the 1940s, Wisconsin Motor Manufacturing Company had completely dominated the heavy-duty air-cooled market. They had found a mechanical niche that Detroit's automotive giants could not touch, and they had filled it with iron that refused to break. The engine had taught an entire generation of American workers to trust its heavy sound. It had not yet solved what would happen when the definition of work began to change. By the 1950s, America was rebuilding itself. The post-World War II economic boom triggered the largest infrastructure expansion in human history. The Federal Aid Highway Act of 1956 authorized the construction of the interstate highway system, demanding millions of tons of concrete, steel, and asphalt. At the same time, American farms were consolidating into massive agricultural operations that required continuous mechanized labor. To build the highways and harvest the fields, contractors and farmers did not just need machines. They needed standalone, heavy-duty power that could operate hundreds of miles away from a paved road, a service bay, or an electrical grid. Wisconsin Motor Manufacturing Company met this demand by scaling its cast iron empire to absolute dominance. If a piece of heavy equipment required anywhere from 15 to 65 horsepower, and it had to operate in an environment that would destroy a standard water-cooled automotive engine, it almost certainly relied on a Wisconsin. The Milwaukee factory was pouring iron at a staggering rate. The product line expanded into massive air-cooled engines like the VG4D and the legendary VH4D. These were not small engines in the modern sense. A Wisconsin V4 could weigh well over 300 pounds. It was a dense, heavy block of cast iron that required a shop hoist or several strong mechanics just to move. But that massive weight was the physical manifestation of its durability. The internal components were radically overbuilt. The engine used Timken-tapered roller bearings, heavy-duty bearings that use conical steel rollers to handle extreme side loads, allowing the crankshaft to endure the violent, jerking tension of heavy agricultural drive belts without failing. Wisconsin engines were bolted to Jaeger concrete mixers, churning heavy cement in the blistering heat of the Nevada desert. They powered Lincoln Electric welders on the high steel of new skyscrapers in Chicago. They were the heart of early Melrose self-propelled loaders, the agile, dirt-moving machines that would eventually become the Bobcat skid steer. In the oil fields of Texas and Oklahoma, Wisconsin engines ran pump jacks and pipeline compressors, operating 24 hours a day, 7 days a week, in choking dust, stopping only for basic oil changes. But the engine's true cathedral was the American farm. Walk into a Midwestern implement dealership in 1958, and Wisconsin was the undisputed king of auxiliary power. New Holland balers, John Deere combines, JI case grain elevators, and Gulf Forge harvesters all relied on the rhythmic, heavy thud of a Wisconsin V4. In an America where an engine could decide whether a field was cut, a truck made its delivery, a boat left the dock, a generator carried a hospital through a storm, or a plane lifted from the runway, power was not an abstraction. It was iron, fuel, labor, heat, sound, repair, and trust. Wisconsin earned that trust through a service network that blanketed rural America. If a massive connecting rod bearing finally wore out after a decade of abuse, a farmer in Nebraska did not have to wait weeks for a factory replacement. Almost every tractor dealer, hardware store, and small-town machine shop stocked Wisconsin gaskets, pistons, and magneto parts. The repair culture around the engine was an American ritual. A mechanic would tear down the engine, take the cast iron cylinder block to a local machine shop to be bored out, a machining process that cuts away worn metal to create a perfectly round, slightly larger cylinder, and install oversized pistons. The engine was not designed to be a consumable product. It was designed to be a generational asset, something a farmer could rebuild and pass down to their son along with the baler it powered. The Milwaukee foundries were running at full capacity, and the Wisconsin badge had become a symbol of indestructible American manufacturing. But this industrial triumph was only the first half of the peak. By the early 1960s, the Wisconsin Motor Manufacturing Company was not just participating in the American industrial market. It owned a specific, unassailable corner of it. Inside the Milwaukee plant, the casting lines were running continuous shifts. The company was shipping tens of thousands of heavy-duty engines a year, and their application list read like a catalog of American physical labor. If an airline needed a baggage tug to reliably pull luggage carts across a freezing tarmac in Chicago, it used a Wisconsin. If a municipal crew needed a heavy-duty wood chipper to clear downed trees after a Florida hurricane, it used a Wisconsin. In the sprawling orchards of California, giant mechanical sprayers were dragged through the rows, their massive fans driven by the unrelenting torque of a Wisconsin V4 running at full throttle. The engine's dominance was rooted in its mechanical governor, a device linked to the carburetor that automatically regulates engine speed, opening the throttle wider when a heavy load is suddenly applied, to keep the RPM perfectly steady. A farmer could engage the clutch on a heavily loaded baler, and before the engine could even begin to stall, the governor would snap the throttle open, commanding a deep, roaring surge of power from the cast iron block. It was a sound that meant absolute certainty. This certainty caught the attention of the ultimate American fleet buyer, the United States military. During the Cold War, the military required mobile, heavy-duty generators and pumps that could be dropped into austere environments and trusted to run without complex maintenance or vulnerable liquid cooling systems. The Wisconsin V4, with its battery-free magneto and air-cooled simplicity, was drafted into service. The military painted them olive drab, crated them up, and shipped them to bases around the world. The Milwaukee factory had become a pillar of both civilian infrastructure and military readiness. By the late 1960s, the Wisconsin catalog offered an engine for almost every heavy-duty, standalone task. They built small singles, robust twins, and the legendary V4s, reaching up to 65 horsepower with the massive V465D. To look at a Wisconsin V4 from this era is to look at a machine built with zero compromises for weight or cost. The sheet metal shrouds directing the cooling air over the cylinders were thick and bolted down with heavy hardware. The oil bath air cleaner, a filtration system that forces incoming dusty air to pass through a pool of motor oil to trap dirt before it can enter the carburetor, was a heavy steel canister designed to survive the worst agricultural environments on Earth. The engine did not just power equipment, it defined the design of the equipment itself. Manufacturers like Bobcat, Ditch Witch, and New Holland built their early machines specifically around the footprint, weight, and power delivery of the Wisconsin V4. The engine was the immovable anchor point of American heavy-duty design. But this scale masked a dangerous vulnerability. The Wisconsin business model relied on an American market that valued longevity over initial purchase price. The engines were expensive to cast, expensive to machine, and expensive to ship. Their massive weight, often exceeding 400 pounds for the larger V4s, was celebrated by the mechanics who rebuilt them. But it was quietly becoming a problem for the engineers designing the next generation of machinery. The American industrial landscape was changing. The economy of repair, the network of machine shops, local mechanics, and farmers who spent their winters boring cylinders and then installing oversized pistons was reaching its peak. A new industrial philosophy was beginning to take shape, one that prioritized lightweight materials, integrated power systems, and cheap components. Wisconsin had built an empire by mastering cast iron. The badge meant indestructibility, but in the changing American market, indestructibility was about to become an economic liability. The first crack in the Wisconsin engine empire was not a mechanical failure, a factory strike, or a sudden bankruptcy. It was almost invisible. It began in the mid-1960s on the dashboard of new American tractors like the John Deere 40-20 and the International Harvester Farmall series. For decades, the Wisconsin V4 had survived because early tractors could not effectively pull a heavy machine and power its internal mechanisms at the same time. But tractor manufacturers had been quietly solving this engineering problem. The solution was the independent or live power takeoff. A live PTO is a driveline system that continues to transfer rotational power from the tractor's engine to the towed implement even when the operator steps on the tractor's clutch to stop moving forward. In a Midwestern hayfield, this changed everything. If a massive clump of wet hay threatened to jam a pull-type baler, a farmer driving a modern tractor could simply step on the clutch. The tractor would stop, but the PTO shaft would keep spinning, allowing the baler's internal mechanisms to clear the jam without losing momentum. Suddenly, the baler did not need its own engine. The economic math for the American farmer shifted overnight. A Wisconsin V4 was a magnificent piece of engineering, but it was also a heavy, expensive, standalone machine that required its own gasoline, its own oil changes, its own spark plugs, and its own winterization rituals. Why would a farmer pay for, fuel, and maintain a 400-pound cast iron auxiliary engine when their new diesel tractor could do both jobs from the cab? One by one, the massive fleet orders that had sustained the Milwaukee foundries began to evaporate. New Holland, John Deere, Gell, and Massey Ferguson redesigned their pull-type combines, forage harvesters, and balers to be entirely PTO-driven. The heavy-duty auxiliary farm engine, the exact machine category that Wisconsin had dominated since the 1930s, was being engineered out of existence. The Milwaukee factory was losing the farm, but the displacement did not stop at the edge of the field. A second, equally devastating force was sweeping across the American countryside, the final stages of rural electrification. In the 1930s and 1940s, a stationary gasoline engine was the only way to generate power in remote areas. But by the 1960s, the Rural Electrification Administration had successfully strung power lines to the farthest corners of the American map. Farms, rural machine sheds, and remote oil fields were finally being connected to the central grid. This introduced a new rival to the stationary engine market, the industrial electric motor. An electric motor, a machine that converts electrical energy directly into mechanical energy using magnetic fields, was a completely different kind of power. It did not require a heavy hand crank to start. It did not require a magneto. It had no carburetor to clean, no oil to change, and no air filter to clog with dust. In the Texas Panhandle, ranchers who had once relied on a roaring Wisconsin V4 to run their deep well irrigation pumps began unbolting the heavy cast iron engines and replacing them with silent electric motors. You simply flipped a switch and the water flowed. In rural dairy barns, the vacuum pumps that powered the milking machines were swapped to electric power. In lumber yards, the heavy saws were wired directly to the grid. Wisconsin found itself squeezed by a terrifying reality. The heaviest, most demanding agricultural jobs had been absorbed by the tractor's PTO. The stationary continuous duty jobs had been absorbed by the electric grid. This left the company highly exposed. They still had a market in light construction, specialized industrial equipment, and heavy-duty commercial mowers. But this remaining market was shrinking, and it was demanding something Wisconsin was not built to provide. Wisconsin's entire corporate identity was built on Force One: iron, aluminum, fuel, and manufacturing costs. They believed in heavy-duty cast iron. They believed in over-engineering. They believed in building an engine that could be bored out, rebuilt, and run for 30 years. But cast iron is incredibly heavy, and the foundries in Milwaukee required highly skilled, expensive union labor to pour and machine it. As the American equipment market evolved, engineers designing new skid steers, trenchers, and portable generators wanted engines that were lighter, more compact, and cheaper to buy up front. The end user was beginning to change too. The old economy of repair, the sprawling network of rural machine shops, local mechanics, and farmers who spent their winters rebuilding engines on a workbench, was slowly thinning out. The Wisconsin badge had meant indestructibility. But the American market was learning that longevity was not the only way to measure a machine's value, and a new rival was already crossing the Pacific to prove it. By the late 1970s, the American industrial and agricultural markets were being quietly invaded by a new mechanical philosophy. It arrived in cardboard boxes from across the Pacific, painted red and carrying names like Honda and Yamaha. These were not heavy, cast-iron behemoths. They were lightweight, compact, and incredibly cheap engines built around a completely different set of manufacturing principles. The most devastating blow came in the form of the aluminum overhead valve engine. An aluminum block, the main engine structure cast from a lightweight alloy rather than dense iron, drastically reduced the weight and shipping costs of the motor. Overhead valve, or OHV, an engine design with the valves located in the cylinder head rather than inside the engine block, allowing the engine to breathe more efficiently and run cooler, made these imported engines highly fuel efficient and remarkably quiet. When a contractor went to buy a new portable water pump or a commercial generator in 1982, they faced a stark choice. They could buy a machine powered by a traditional American cast iron engine, which was heavy, expensive, and required two strong workers just to lift it into the back of a pickup truck. Or they could buy a machine powered by a Japanese aluminum OHV engine, which weighed a fraction as much, started easily on the first pull, and cost significantly less up front. The market did what markets always do. It chose the cheaper, lighter option. This shift exposed the fatal economic flaw in Wisconsin's business model. Wisconsin engines were designed to be generational assets. They were built for a time when American mechanical culture was defined by the workbench. But in the 1980s, the American economy was rapidly moving toward replacement culture. Imagine an American farmer or a rural repair shop mechanic looking at a worn-out Wisconsin V4 that had finally lost compression after 20 years in a hayfield. The mechanic calculates the cost of the overhaul. They have to completely disassemble the heavy block. They have to pay a local machine shop to bore out the cast iron cylinders. They have to order specialized, expensive, oversized pistons, new rings, and heavy-duty gaskets. The labor and parts might cost $600 or $700, and the equipment will be down for a week. Then the mechanic looks at a parts catalog. For less money than the cost of rebuilding the heavy American iron, the farmer could simply buy a brand new, lightweight aluminum engine in a box. They could unbolt the Wisconsin, push it into the corner of the shed, bolt the new aluminum engine onto the equipment, and be back in the field by the afternoon. The engine did not fail. The math failed. As the economics of repair collapsed, forced to, dealers, fleets, farmers, pilots, and service networks turned against the Milwaukee factory. A mechanical empire only survives as long as its service network is willing to support it. Tractor dealerships and small engine repair shops looked at their parts counters. Storing massive cast iron pistons, heavy magneto assemblies, and complex carburetors was taking up valuable shelf space for engines that were increasingly being thrown away rather than fixed. Slowly, the dealers stopped ordering Wisconsin parts. When the parts became scarce, even the dedicated mechanics who wanted to rebuild the old engines found it too difficult and expensive to keep them alive. The company attempted to survive through corporate consolidation, the process where companies merge, acquire, or absorb other companies in an attempt to pool resources and survive market changes. Wisconsin Motor Manufacturing Company was acquired and absorbed, eventually operating under the banner of Teledyne Wisconsin Motor. Under corporate pressure to compete with the lightweight imports, Teledyne attempted to pivot. They began importing and rebranding smaller, lighter engines, famously partnering with Robin, a Japanese manufacturer, to sell the Wisconsin Robin line. But this only accelerated the brand dilution, the weakening of a brand when the name remains but the original product, factory, or identity changes. A farmer who bought a Wisconsin Robin engine was not buying the indestructible Milwaukee cast iron they remembered from the 1950s. They were buying an imported aluminum engine with a legacy American sticker slapped onto the recoil starter. The badge remained, but the trust, the deep physical certainty that the engine would outlast the machine it was bolted to, was permanently broken. By the time the 1990s arrived, the foundries in Milwaukee were a shadow of their former scale. The massive fleets of heavy-duty pull-type agricultural equipment were gone, replaced by powerful tractors with live PTOs. The remote oil fields and rural farms were electrified. The portable construction equipment market had been entirely captured by cheap, disposable aluminum power. The heavy-duty, air-cooled cast iron engine was no longer a solution. It was a relic. The block was still solid iron. The engineering was still bulletproof. The engine still ran. The fleet orders slowed. The tractors took the work. The service network collapsed. The parts got harder to find. The factory line moved. The heavy sound faded. The badge remained. The world it was built to power was gone. By the dawn of the 21st century, the original Wisconsin Motor Manufacturing Company was effectively a ghost. The corporate consolidation that had turned it into Teledyne Wisconsin Motor eventually fractured. The branding was licensed, traded, and attached to various overseas products, most notably through a partnership with Subaru Robin. But the massive cast iron V4 engines, the heavy-duty, air-cooled blocks that had once dominated the American agricultural and industrial landscape, were no longer rolling out of the Milwaukee foundries in any meaningful volume. The era of the standalone auxiliary farm engine was officially dead, replaced by the live PTO, the rural electric grid, and the cheap disposable aluminum import. But old American iron rarely vanishes cleanly. It simply enters its industrial afterlife. If you walk through a farm auction in Iowa, a salvage yard in Pennsylvania, or a sprawling antique tractor show in the Ohio countryside today, you will not just see green and red tractors. If you listen closely, you will hear a distinct, heavy, rhythmic thud coming from the edge of the fairgrounds or the back of a barn. It is the unmistakable sound of a Wisconsin V4, often a legendary VH4D, pulled from the rotting chassis of a scrapped 1950s New Holland hay, baler. These engines did not go to the scrapyard when the equipment they powered finally collapsed. Because the balers, combines, and concrete mixers were made of thin stamped steel, they eventually rusted out, fatigued, and broke apart. But the Wisconsin engine bolted to the top of them was cast thick. It survived the elements. And across rural America, mechanics, farmers, and fabricators unbolted those heavy cast iron blocks and gave them a second life. Today, the ultimate retirement home for a Wisconsin V4 is the homemade American wood splitter. A fabricator will weld a heavy steel I-beam to a trailer axle, mount a massive hydraulic ram, and power the entire rig with an old Wisconsin engine. They do this because splitting thick, knotted oak requires immense, sudden surges of torque. A modern, lightweight aluminum engine will bog down, scream, and struggle against the sudden hydraulic load. But a Wisconsin V4, with its heavy steel crankshaft, massive flywheels, and mechanical governor, does not care. When the hydraulic wedge hits a tough piece of wood, the governor snaps the throttle open, the engine barks a deep, roaring exhaust note, and the ram pushes straight through the oak without losing a single RPM. This preservation is not merely nostalgia. An old Wisconsin engine strapped to a homemade wood splitter or displayed on a rolling cart at an engine show is a physical argument about how America used to understand the value of a machine. It is a working relic of a vanished economy, the economy of repair. When you look at a running Wisconsin engine today, you are looking at a time when a broken connecting rod meant a trip to the local machine shop, not a trip to the hardware store to buy a plastic-shrouded replacement. You are looking at an era when a piece of equipment was designed with the explicit assumption that the person who bought it possessed the skill, the tools, and the economic incentive to take it apart and fix it. The survival of these heavy blocks proves that American foundries once possessed the metallurgical skill and the machining precision to build a power plant that could outlast the original buyer, the equipment it was bolted to, and the very company that manufactured it. In the garages and machine sheds of the enthusiast community, the old service manuals for these engines are treated like sacred texts. They are thick, spiral-bound books, usually stained with decades-old motor oil and thumbprints. They contain step-by-step instructions for tasks that modern consumers are no longer trusted to perform: how to bore a cylinder, how to measure bearing clearances, how to rebuild a magneto, and how to set the mechanical governor. These manuals are proof that the American service network was once a partnership between the factory and the end user, rather than a closed system designed to force a new purchase. The Milwaukee Industrial Corridor, where these engines were born, has long since transformed. The massive casting lines and the ranks of highly skilled union machinists who built the V4s have been replaced, relocated, or quieted. The American market made its decision. It decided that a 400-pound cast iron engine was too heavy, too expensive, and too permanent for a world that wanted to move fast and travel light. The market did not kill Wisconsin because the engines were weak. It killed the empire because the engines were too strong for an economy that learned to profit from replacement. But out in the rural Midwest, the iron refuses to acknowledge the bankruptcy. The mechanical certainty that Wisconsin promised still exists, trapped inside the heavy castings, waiting for someone strong enough to turn the crank. Somewhere in an American machine shed, an old Wisconsin V4 sits quietly in the corner, the heavy iron cooling fins covered in dust, the thick oil bath air cleaner still clamped tight, waiting for a spark from its magneto and a task heavy enough to demand its power. See you in the next video.